In this series of lessons, we'll explore a few different methods for actually simulating the effect of underwater caustic patterns within Maya. Alright, so the caustic patterns that we're going to be creating are the type that you would normally expect to see on something like the bottom of a swimming pool, where we have water at the surface that's actually refracting the light and focusing it into these small little patterns of light, or caustics. So there's a couple of different ways with Maya that we can actually go about doing this. So we'll explore a few different methods, and as well we'll start to talk about some of the pros and cons that you can expect to experience with each of these methods. Right, so the first method we'll explore is actually using mental ray caustics to generate this type of an effect. So if we take a look at the scene that we have currently, you can see this is really just a very simple scene, a very simple box with just a plane up top. So what we'll try to do is actually make this plane simulate the water surface, and then we'll start to add our caustic patterns in afterward. All right, so let's go ahead and jump over into the hypershade to begin with. I'm going to start over in the mental ray nodes, and for the water surface I like to start with something like a nice dielectric material. This is actually good for simulating transparent refractive surfaces like water or glass. Now once I drop this in, I'm going to expose the output connections for this so that I can gain access to the shading group. Now with this exposed, let's go into the Maya nodes and let's create our water pattern. So a good node for this would be something like the ocean. There we go. Now I'm going to make just a few minor adjustments to this so that it's a little bit more water-like. We'll start with this wave height and just start to bring this up and quite a bit further to the left so that we can start to get a lot more contrast in here. As well, I'm going to start to take this wave peaking attribute, same as before. I'll bring this up and very far to the left. Again, so that kind of starts to get a little bit more of a peaking pattern in here. And then we can also take something like the wavelength minimum and maybe just start to expand this and bring this up just a very slight amount just so we can start to see some of these individual waves. Alright, so I'll go ahead and just call this good. And now, let's take this shading group for this dielectric material, and here in the displacement material, let's just middle click and drop this ocean in here. Right, so for the displacement, this ocean is probably going to be giving us some really, really high and strong waves. So what we'll probably have to do is come into this color balance and make sure alpha is luminance is turned on. And with that active, let's come in and now drop this alpha gain quite a bit, so that way the displacement height isn't nearly so strong. Right, so now we can take this dielectric material, middle click, and drop this onto our water surface. Alright, so let's just see what this does for us. Alright, so you can see that does now give us some nice water displacement effects on the surface of this plane. Now let's start to come in and actually add in the caustics. Now, as a matter of personal preference, because caustics, you really have to have a lot of photons in order to get a nice, clean result. So, in order to keep these photons nice and focused, what I always like to do is use something like a spotlight as my caustic photon emitter, or even my global illumination photon emitter. So let's take this spotlight, look through selected, and I'll try to aim this roughly in the same direction that this directional light is pointing. So kind of right in here, and just far enough away to where it is basically encompassing everything. Alright, so let's go back to the perspective view. And if we take this spotlight, really I don't want to interrupt the lighting that we already have, so I'll strictly use this light as a photon emitter. So we can just take its light intensity, bring this all the way down to 0, and we can have totally independent control though over the direct light and the indirect lighting. So even though the light intensity is 0 for the direct lighting, we can still come in and have this emit photons, and the energy that they contain is completely independent. Right, so let's tell this to emit photons. Now you notice the attribute for the caustic photons is still grayed out. That's because we don't actually have the ability to calculate these caustic photons enabled yet. So let's go into the mental ray render settings. Inside the indirect lighting tab, let's pull open the caustics and enable that. Alright, so let's come in and see what we have. I can just turn on my resolution gate, try to frame this up a little bit better, and we'll see what this does for us. And the rendered result that we get, we can actually start to see the caustics having some kind of an effect, but really right now it's just a big blown out mess. So a few things that we're going to have to do in order to fix this. The first thing is that obviously the energy of these photons is way, way too high, so we'll have to adjust that. And then we'll probably have to come in and start to actually increase the number of photons, because right now you can see a lot of these individual kind of blobs in here. So let's start with the photon intensity. Right now it's set to 8,000. This is a value that's very, very dependent on your particular scene size and just how far the light is from the object that's receiving these caustic photons. So in my case, the default value is obviously way, way too high. So let's try to bring this down quite a bit to something like maybe 1,000. And now with these caustic photons, now that we've enabled this inside the render setting, you can see this attribute now becomes available. And the default value of 10,000 I find is usually way too low. So a good starting point I find is something like 100,000 or even 500,000, just because you do need a lot of caustic photons in order to get a nice sharp result. All right, you can see that's actually done a lot to help us. These photons are not nearly as blown out as they were before, and by adding quite a few additional photons cast into the scene, you can see that now that's starting to give us some slightly sharper results. Now, although I'm still really not satisfied with this, so let's come back and maybe start to give this some more caustic photons. Right now we're working with 100,000. Let's bump this up a little bit higher to something like 500,000. And re-render this. There we go. And you can see now with more photons, we're starting to get some definite sharper results compared to what we had before. Although you will start to notice, though, as you begin adding more photons, your render time will also start to slow down quite a bit. So definitely be careful with just how high you take this. Another thing we may be able to do with this, as far as starting to get some slightly sharper results, is to actually take this caustic radius and start to actually define some kind of a value. Right now it's set to 0, which means that Maya will automatically try to determine what the base value should be. But what we can start to do is begin introducing some kind of a value into this. Now ideally we want this to be something nice and low, because what this is essentially going to do is define how far each caustic photon is able to look for any neighboring photons and start to average that result together. We want to give it a low value because we don't want these photons looking in too large of an area, because otherwise we're going to start to get some soft and blurry results. So I always find it useful to start with something really, really low, and then if I need to, I can always gradually start to bring this up. All right. And looking at this, it doesn't really look like that made a tremendous amount of difference. But if we started to introduce even more caustic photons in here, we should even start to get some sharper results. Now we can go back to our render settings and go back to the quality tab. Let's just maybe start to increase our sampling level so we can get some slightly smoother rendered results. Maybe render this from a slightly different angle. And we can actually see the caustic patterns that are being refracted through this water. Now in my case, the waves may be a little bit too high, so we could always try going back to the dielectric materials displacement, which is this ocean, and maybe even try to drop this alpha gain a little bit more. Let's try something like 0.05. And while we're at it, let's go ahead and go into the quality settings and start to increase the ray tracing amount. Right, so that way we can maybe try to prevent any interference from these rays and maybe try to make sure that these rays are able to get back to the camera without any problem. There we go. You can see now those waves are a little more subtle, and that just makes it now a little bit easier to actually see these caustic patterns. So this method that we've just gone through is good if you actually need to be able to see the surface of the water and actually be able to see the refracted caustics underneath. Now, this method is really not so good if you actually have to simulate some kind of a large body of water, like an open ocean or something like that. The other problem with this is that because of the number of photons that we have to use, again, because we have to use so many photons and concentrate those into such a small area, that if we were to try to simulate any kind of a large body of water, it really just becomes almost too much. We just have to use so many photons that it's probably likely the scene won't even be able to render at all. But like I said, for large or rather small bodies of water and situations where we actually need to be able to see the water's surface, this will work just fine. Now, what we'll do in our next lesson is actually look at an alternative way of setting up these types of caustic patterns, one that's actually going to be much better used for some kind of a large open body of water like an ocean.